Whoops, that's not what, there we go. Okay, I'm recording now. All right, so let's just look at the agenda for day 3. We're going to do a couple more labs today. So in the morning, I'm going to set it up a little different. Instead of starting out with the breakout groups, I'm going to start out showing you how to pour gel and run the gel. And as the gel is running, and the system I'm going to use is the MiniOne system, and I'll talk more about that later. It only takes about 15-20 minutes to run the gel. As the gel is running, that's when I'll put you in your breakout groups to type in your activities for units 3 and 4 and have some time to share ideas and such. I want to thank you guys for all the great feedback you're giving me. One theme I saw in yesterday's feedback was that some of you would like more time for sharing best practices and sharing ideas, and you'll probably have about 20 minutes of that just this morning while we're waiting for the gel to run, and I put you in breakout groups. After we get our results, and one of the reasons I like the MiniOne system is you can get your results in like half an hour. I'm going to take you through how to do the graphical analysis of the results, how to make the standard curve on the semilog graph paper, which I think is a step that too often teachers skip, but I think it's a really great opportunity to get your students comfortable with a different type of graph. And I think it's worth taking the time to do it because it's going to make your kids so much more confident when they see a graph they may not have seen before on the test. So that's what we're doing during synchronous time this morning. And then during asynchronous time, I'm going to ask you, and this is super important for this afternoon, to watch the pre-recorded video I made on water potential, which has to do with the diffusion and osmosis lab that we're going to do after lunch. And then I also built in some planning time for you in the morning. Also, during your asynchronous time on the agenda, I put a link to the AP Biology's the AP Biology Facebook group's Google Drive, because there is a Google Drive connected with that Facebook group that has a whole bunch of wonderful resources in it. So during your asynchronous time, you might want to check that out. I hope I'm not overwhelming you guys with all these resources I'm sending to you. So the one time someone told me they felt like the workshop was drinking out of a fire hose, and I'm sorry about that, but I just want to throw a bunch of stuff at you, and you can pick and choose like 2 or 3 things you think are useful that you can use. All right, then we'll break for lunch, and in the afternoon, I want to talk about the instructional planning report really briefly, which is a special summary of your students' AP exam scores that the teacher can access. And then I'm going to show you how to set up and prep the diffusion and osmosis lab, and we'll do a little bit of data analysis on that as well. And then for the rest of the afternoon, I'm giving you some more asynchronous time to check out some of my favorite virtual labs: virtual gel electrophoresis, Pearson Biology Lab Bench, the Lizard Evolution Lab from BioInteractive. And are any of you familiar with Harvard's Lab Exchange site? Okay, I see at least one. I see Shauna nodding. This is kind of new. They just released this in the spring, and Harvard has started this free site called Lab Exchange, where they have thousands of curated resources for teaching primarily about the biological sciences. They have some stuff for chemistry, and it's geared for pretty high level high school, or like AP, or college kids. And recently, and you can they have this and it's free. And they have this function where you can make pathways connecting the different resources. And recently they released 6 pathways to go with the first 6 units of the AP biology course. So I'm going to be using some of those in my class. So that is what we're doing today. Are there any questions? Okay, I don't see anyone in the waiting room. Oh, and can I have a volunteer to monitor the chat for me this morning, please? Thank you to the persons who did it yesterday.
Yeah, I can monitor this morning.
Do it.
Okay, I don't know who. I think I heard 2 people. I don't know who that was, but who's going to do it? Or you can both do it. It doesn't matter, as long as someone's doing it. Okay. All right. Great. Okay, so I'm going to share my screen here, and just a little background information about gel electrophoresis. What you do, so you have the kids pour an agarose gel, and in the agarose gel, you use a little setup that makes a few little holes at the top, or wells, and that's where you're going to put your DNA. Okay. The DNA, because of the sugar phosphate backbone, in the buffer, you put the DNA in. The DNA has a slight negative charge because of that phosphate group. So you hook this electrophoresis gel up to some electrodes, and you put the negative electrode up here, the positive electrode down here, opposite charges attract. So the DNA starts to move through the gel. Now, if we could take a cross section of this gel, so this is a cross section of the gel, and if we could look at it under a microscope, you would see all these microscopic pores inside the gel. And the analogy I make with my students is that it's kind of like a sponge. You know, a kitchen sponge has a whole bunch of holes of various sizes. Well, that agarose gel is going to have a whole bunch of holes too. And these pieces of DNA have to work their way. Let's see, if this is the negative end and this is the positive end, okay? These pieces of DNA have to work their way through those holes. And the longer pieces are going to get more hung up. And the shorter pieces are going to have an easier time of working their way through the gel. So what you do, you get a series of bands on the gel, and the shorter pieces, this pen is almost out of ink, the shorter pieces will migrate further, and the longer pieces will be closer to the top of the gel. Does that kind of make sense, you guys? Okay. Now, the system we're going to use, there's lots of different gel boxes you can use to do this lab. And this lab is probably one of the more, probably if not the most expensive lab to run, because the equipment, you know, to do it with a class of 30 can run into the thousands of dollars. But there's a couple different ways to do that if you don't have the equipment. Are any of you familiar with, what's the name of the organization? The Amgen Biotech Experience? Okay, you might want to write that website down. It's Amgen Biotech Experience, and check it out later. I know if you're in the LA or San Diego area and here in the San Francisco Bay Area, this is run out of Amgen. It's completely free. You attend one of their workshops, and once you attend their workshop, you can check out all the equipment you need to do the gel electrophoresis lab or the bacterial transformation lab for free, and they even give you the reagents for free. All they ask is that you attend one of their free workshops first, so they know you know how to use the equipment and you're not going to break it or something. And does that kind of make sense? Any questions on that? And if you wanted, they are in other places around the country too. So if you go to their website, there's a little map you can click on and it'll tell you where their service area is. Okay.
So now, is their workshop online or?
Well, that's interesting because their workshop is usually in person because you actually get to use the equipment and try it out. So I don't know what their plans are for this coming year, but but it would be worth contacting them to ask them. I mean, theoretically, they probably could still do their workshop in person if they limited it to a few enough people, right? But
there's another company that I was told about from another workshop that's pretty amazing. You buy their gel electrophoresis kit, comes with everything, and it's so user friendly, and it's really hard to mess up, you know, the lab. So if you want, I could link that somewhere.
Would that happen to be MiniOne? Is that MiniOne? Yeah. That's what we're going to use today.
Okay, perfect.
Yeah. I used the BioRad gel boxes for years, and I love the BioRad gel boxes. I think they're really good quality. I think when your students go off to college, they are probably not unlikely to use the BioRad gel boxes because they're used in industry as well. But the trouble is that the reason I switch is like these MiniOnes, a couple of reasons. You'll see it as we go through it. When you run the gel, instead of having a skinny platinum wire like most gel boxes do, they have this big old steel rod, which is virtually unbreakable. I mean, because, you know, I've been teaching, gosh, 30 years now. And, you know, every once in a while, some kid would get a little overeager when they were cleaning out the gel box at the end, and then they'd break that platinum wire, and those are expensive and a pain. The other thing I really like about this MiniOne system, I get nothing from MiniOne. Okay, I don't get a commission or anything like that. But the other thing I like about the MiniOne system is that their agarose comes in these little cups.
Yeah,
The
that's
agarose is
godsend.
pre-made, and it already has the dye added to it. So all you have to have the kids do is pop this in the microwave. They pour their gel, and because the dye is all, and this is a safe dye, it's not ethidium bromide. Those of you who are old like me and remember the days of ethidium bromide, you have to be careful with it because it's a carcinogen. This is completely environmentally safe, the dye they use. And because the dye is already in the gel, and they have a UV light built into this box, once the gel is running, and you'll see this in a minute, you turn on the light and you can actually see the kids can see the DNA migrate down the gel in real time. And what teenager doesn't like instant gratification when they're doing a lab, right? I mean, I kind of like it. It's kind of cool. So they can actually see it move through there. So I really
Mary,
like that. Yeah.
Just so you know, the chat says from Megan, Amgen rocks. From Sean, sorry, I don't think I'm going to get the name right. The comment is the San Diego Safari Park has a teacher conservation institute that does something similar. You can check out a whole gel kit for analyzing condor genetics. Don't know if they're
Wow.
adapting it to remote learning.
Great.
So you know.
Thank you, Nicole, and thank you for contributing those to the chat. Okay.
So the San Diego Safari Park is actually doing theirs in person still this summer because I have a few friends that attended it.
So they're probably just limiting the number of people or something so they can stay safe.
Exactly.
Yeah. And I think it's different doing a lab in person with adults than it's going to be with kids, right? Because one would hope the teachers are going to follow all the rules and stuff. You know, our district has not released any policy on this yet because we're going to be remote for at least a few weeks. I'm guessing probably longer. But I have heard of other districts, other teachers in the Facebook group are saying their districts are saying no labs if it involves shared equipment. So that's going to kind of be a challenge. All right. So here's how you pour the gel. So in the MiniOne system, it comes with this little tray. It's got an insert here. This tray, you can pour 2 separate gels at once. We're just going to do 1. Okay. And then you have this. This is called the comb, and the comb has teeth on it. And this fits in up here. And I don't know if you guys can see it or not. The comb does not touch all the way to the bottom. There's a little bit of space. I think you guys can probably see that. There's a little bit of space between the bottom of the comb and where you pour the gel. And what that's going to do, it's going to make the wells. It's going to make the little divots in the agarose that you're going to load your DNA into. And you might notice there's 2 sides of the comb. A side with bigger teeth and a side with smaller teeth. One way if you do decide to buy your own equipment to have in your classroom for this, one way you can conserve materials and save a bit of money is if you use the smaller teeth, you have enough wells for 2 groups at a time to run their samples on 1 gel. So instead of having 1 gel per group, you can have 1 gel for every 2 groups. But I'm going to use the bigger one. Okay, and then all I do is I take this cup and I microwave it for 30 seconds. And you just have the kids peel this back to vent it so that it doesn't explode in the microwave. And I'll be right back. I'm gonna go next door into my kitchen and pop this in the microwave. Blackberry, be quiet.
I highly recommend everybody apply to go to the conservation at the San Diego Safari Park if you've never attended. The year I went, I got to be there with a bunch of people from all over the world, but they take people from everywhere, so they're amazing.
Is the San Diego, is that like a paid one that you do, or is that more of a something they just set up for teachers and that's it?
It's just for teachers. You don't pay anything.
Oh, that's
It's
great.
just really, it's hard to get into sometimes because it's limited. Um, you probably have to pay for travel. I don't know, because most people do it that are from here, but the year I did it, there were people from Africa and Central America, and it was amazing. But they paid for everything. They set us up in a hotel. It used to be that you could be in the tents and you got to sleep in the park. But the year I did it, they started having us stay in hotels, which I know they did that this year too because of COVID. So,
That's cool.
but yeah, it was amazing. It was,
I'm going to interrupt
yeah.
for a second before this solidifies. So I just microwave that for 30 seconds. You want to caution the kids because boiling agarose is pretty hot. And you can microwave like 3 of these cups in the microwave at a time. Sometimes the more cups you have, it might take a little bit longer. And you swirl it around, you pull in there, and in about 10 minutes, it'll solidify. Go ahead, finish up what you were saying.
I was pretty much done. I was just
Oh.
saying, I was just highly recommending the San Diego Safari Park Conservation workshop. It's a week long, and it's I went in August, so you drink a lot of water because it's really hot there in August, but it's amazing.
Yeah, I've heard. Yeah, you know that I think about it. I think someone from our school district did that a couple years ago, and really liked it. Now I'm looking for the scenario that goes with this. One of the things I like about this lab in particular is the scenario they made around this lab. Okay. So I'm pulling up the PTC Genetics Student Mini Lab Guide that goes with this kit from MiniOne. And I'm just going to give you the brief version of the scenario. If you're not familiar with PTC, it stands for phenylthiocarbamide, and it's a really bitter taste. And it's a trait that's dominant. So if you're a taster, that's the dominant trait. So if you're a taster, do we know your genotype for sure? Yes or no? Since it's a dominant trait, if you're a taster, do we know your genotype for sure?
No. Be
No.
homozygous or hetero.
Heterozygous or homozygous dominant.
Right. You could be homozygous dominant or heterozygous. If you're a non-taster, then we do know your genotype, that you have to be recessive. Okay, so there's a bunch of cool background information about how this was discovered and the trait and stuff and the different kinds of the different alleles that are involved. And here's the scenario. The scenario is right here. The person in yellow, this is Jane, I think her name, or Jillian. Jillian is a non-taster. Okay, but both of her parents are tasters, and everyone else, including her brothers, are tasters as well. So Jane's a non-taster, both her parents are tasters, and all her brothers are tasters. So what we have here is what we're going to load a marker. We're going to load mom's DNA, dad's DNA, Jillian's DNA, her brother's DNA, and I think this is her grandfather's DNA as well onto this gel. Because what we're trying to find out is that what the genotype is of the other members of our family, because since everybody else is a taster, we don't know what their genotype is. We don't know if they're homozygous dominant or heterozygous. Does that kind of make sense? So that's the scenario we're going to use. All right. Questions on that? Okay, so let me go back to, whoops, that's not what I wanted to do. Sorry. Go back over here. So it takes about 5 minutes or so for this to solidify. Now, the other thing you need as you run this, you need to make up some running buffer, okay? And in most of the kits, like in the BioRad kits, in the MiniOne kits, they usually send you the buffer in a 10x concentrate, which means 1 part of the concentrate to 9 parts water. Because this whole thing's going to go in the chamber and you're going to pour the buffer on top. And the buffer does a couple different things for you. I mean, obviously it helps maintain pH, but this is an opportunity for you to cycle back to water, properties of water and hydrogen bonding. Because since the buffer is mostly water, the buffer is going to have a high heat capacity. So as you pass electricity through this gel box, it's going to encounter some resistance in the gel. That resistance is going to build up some heat, but the water in the buffer is going to help absorb that heat so that your gel doesn't melt. And the water, of course, is going to conduct the electricity through the gel. So let me open up this concentrate of the buffer. And where is my, looking for my graduated cylinder. Oh, I think I left that in the other room. Excuse me, one more time. I'm going to go get the cylinder with water. I think my husband's been incredibly patient with me this summer, letting me take over the kitchen with all my graduated cylinders and bottles of different kinds of chemicals that are definitely not sounding like kitchen things. Okay, so I'm just going to check and see if this gel is solidified all the way. Usually you can tell if the gel is solidified because it gets kind of translucent. The other way you can check, here, I'm just going to zoom in here so you can see it a little better. Okay. The other way you can check, I just take a pipette tip, okay, and I just have the kids poke a pipette tip at the corner of the gel that's opposite of where the wells are. You guys see what I'm talking about? So that made a little bit of a divot in the gel. So I can feel that it's pretty solid, but it's not quite all the way there yet. I'm going to give it a couple more minutes. And the reason I have them check it down here is that you rarely run the DNA all the way down to the bottom of the gel anyway. So if it's not solidified and you end up making a tiny little, tiny little divot in the bottom like I just did, no harm, no foul. It's not going to affect the results. All right. Any other questions so far?
In the chat, not a question, but the website for the Institute of San Diego Zoo.org teachers workshops is there.
Oh, great. Thank you. Okay, so I'm going to get this next step.
I have a question for yesterday's floating leaf.
Yes.
Did you record that?
I did not record that, but Paul Anderson has a really excellent video on bozemanscience.com on how to do the floating leaf disc lab. I think
Okay. Because I've seen the other one by like Brad something, but
oh, Brad Williamson. Yeah, he's the one who actually wrote the lab for the
okay. So it's basically the same thing.
Right. Okay. I'm running out of plugs here. I got to figure out where I'm going to plug in my gel box. Let's see. Okay. All right. Let me put the cord down here. Our house was built in 1959, and these older houses, they just don't have as many plugs and stuff as newer houses do. Okay, where'd that cord go? Okay. All righty. Okay, so I got this plugged in. I'm confident that our gel is solidified. Well, let me just double check one more time. Yeah, our gel is solidified. So when you pull this comb out, you just want to pull it up slowly with equal pressure on both sides. Wait a second, why is it not coming out? There we go. There we go. Okay. And then you lift this plastic insert. See, here's a plastic insert without the gel. This was in there. So you lift that up. The one and only thing I don't like about this system And it actually didn't happen today. Sometimes the gel overflows a little bit and gets on the bottom of the tray, but that looks like that didn't happen today. So good. All right. So here's our chamber. Whoops. Oh, geez. Okay, got it. Save. You guys have never done that, right? Okay, the chamber has a little black plastic insert that has the markers for the wells, which is kind of handy because it provides a dark background as a target for when the kids load it. Okay, so I'm gonna take this gel. I'm gonna pop it here in the chamber. It just goes right on top of that. And then I take my buffer that I just diluted up with distilled water. And for these biotech labs, for running the gels and doing bacterial transformation, you definitely want to use distilled water for that. And I think I need a little bit more buffer. Excuse me for a second. I'm gonna make up a little bit more buffer for that.
I just looked up at the San Diego conservation thing because I do live in San Diego, probably about 20 minutes from the wild animal park. And I saw there's a $2,000 fee to attend. Can someone confirm that I'm looking at the right program?
It looks like to me you might be looking at one of the ones where they go to another place.
I think you can apply for a spot. I'm looking at the website. It looks like it says if you want to guarantee a spot, not through the application, which gives you a full scholarship, but if you want to guarantee a spot, then you can pay the $2,000 to guarantee your spot, or you can apply. I know they like teacher teams, so if you can get somebody else from your school to apply with you, that might be better.
Okay, thank you.
Thanks for your patience with me popping in and out of the room. There we go. Okay. I probably didn't need that much buffer, but I just wanted to make sure. Okay. So when you add the buffer to the chamber, how much buffer you make up depends on what gel box system you're using. For these mini ones, it's about 130 mils. You want to make sure that the gel is completely covered, but you don't want the kids to fill the chamber up to the top with the buffer, because the more buffer there is, the more resistance there's going to be in the chamber, and the slower the gel is going to run. Does that kind of make sense? Okay. Now I'm going to turn on the backlight here. I don't know if you guys can see it that well. Okay. There's a little, you guys are probably getting a whole bunch of glare on yours. Let's see if I zoom out, if it's a little bit. Yep. Sorry, am I making you guys dizzy? So do you see how that light kind of backlights those wells though, there for the kids? Okay. So I've got my DNA samples here. I'm going to start with our marker, because let's talk about what a DNA marker is. DNA marker is a sample that has pieces of DNA of known fragment sizes, known base pair lengths, and the marker is what is going to be like your reference point. In a way, it's kind of like the control, because it's what you're going to compare everything else to. So I'm going to load my marker up. I always put the marker in the very first well. Okay, and the samples that come with this particular lab from MiniOne already have the dye that we use to visualize the DNA added to the marker. Now, before I load this, okay, a piece of advice: if your students have never used a micropipette before and have never used a gel box before, you absolutely should have them practice using the micropipetters and practice loading a gel before they do this lab. Because this lab is pretty time intensive and resource intensive. You don't want it to not work because your kids weren't confident using the micropipetters. You get what I'm saying? And on the MiniOne site, they have like a free activity that you can download called Pipette Art. If it's not already in the Google Classroom, I'll put it up there later this morning, which is kind of cool, where you give the kids different colored solutions of water that you just make up with water and food coloring, and you give them a laminated piece of paper, and they practice using different volumes of dots to, like, it's kind of like pointillism or something in art, and they make like pretty pictures and stuff, but definitely worth taking the time to do that. Okay. Also, another piece of advice, when you have the kids load the gel, sometimes their hands are a little shaky. They can just rest the side of their pipette against the side of the gel box to steady it if they want to. But what I think is really important is that, and I'm going to stand up, they get their eyes right above the well. They want to load their sample in, and they want to just barely prick the surface of the buffer. Okay. But not poke the gel, because if they poke the gel with the pipette tip, whoops, I didn't do a very good job loading that sample. I lost a lot of it. I'm going to load a little bit more marker in there because I have extra. Because if they poke the gel with their pipette tip, they could make a hole in the well and then lose their sample. Okay, I don't know if you guys can see that very well from your view. Let me see if I turn this off. Is that any better? No, that's worse. You can put the light at a couple different levels. Anyway, so that's my first sample. And you want to have them change tips each time. I don't know if you guys can really see that too very well. That's too bad. Okay, and then in the next well, I'm going to put where's Jillian? Here's Jillian. I did a better job with that sample. And then in the next well, we're going to put Mom. Next, we're going to put Dad. And I don't know if you can see, I'm changing pipette tips each time so we don't have cross-contamination. And then we're going to put brother number 1. I think it's kind of sad they didn't give the brothers names. I mean, come on. But here's brother number 1. And brother number 2. And I only used 6 wells for this gel, so I don't have room for Grandpa because I want to have the DNA marker. Actually, you know what? I do have room for Grandpa because I'm looking at the tube of brother number 2, and it looks like I don't have enough DNA in that tube, so I'm going to go ahead and put Grandpa in there. Oh, where'd Grandpa go? Okay, I don't have Grandpa's DNA, so we'll just do those. Okay, so I got my gel loaded up. Okay, and then you have, where'd I put it? You have this little orange hood that you can put over this. That way you can turn on the UV light, and it protects the kids from looking at the UV light directly because the UV doesn't get through here, but you can still see. All right, so I'm going to turn on the gel, turn on the UV light, and it should be running. And what's kind of nice about this hood they built in here, it's got a little hole on the top that kids can, I'm pulling out the camera on my phone, that kids can put their cell phone camera on top of. Does everyone see what I got here? Can you guys, let me see if I can move that out a bit. Well, you guys are getting a considerable amount of glare there. Let's see if I do this. Is that a little bit better? It looks a lot better from my viewpoint because I'm not getting the glare on the sides. But what the kids can do, they can put their cell phones here and they can hit the record button. And, oh, that looks a little bit better. Let me zoom that out. And they can actually record the DNA running through the gel in real time. And let me see if I can adjust the light a little bit. It's kind of hard to see, but do you guys see like right about here? Do you see kind of those glowing green lines right below the wells? Okay, that's the DNA already entering the gel. It's that fast. And it'll get down to the bottom of the gel in about 15, 20 minutes, okay? So I'm gonna go ahead and record this on my phone. Now my phone's a little lopsided, so I need something to kind of weight my phone down so it stays on top. Nope, that's not gonna work. Let's see. Looking for something heavy here. All right, I'm gonna have to move my phone because I can't reach it. Okay, let me line that up again. Okay, I'm gonna put that right there. I'm just looking for something to weight this down. A little piece of ceramic that my daughter made me. Okay. All right, can you guys see how the DNA is already entering the gel and running through there? It goes really super fast. Now, I know there's a couple of you in the group who teach biotech electives. Do you have any recommendations or anything you want to add about equipment to use for gel electrophoresis?
I would say if you have the gel boxes like that are kind of translucent on the bottom, something that helps kids with loading is to take a piece of that colored lab tape and put it flat on the table and then line the wells up over top of that. It helps them see the wells a little bit better.
Yeah, the black on black is kind of hard to see sometimes, isn't it? Anything else? Tor, I think you need to unmute yourself.
Okay. We do a lot of practice with basically making a gel that has like tons of combs in it and tons of holes and then giving it to people and have them practice loading just colored water so that they've got a lot of practice because the shaky hands with the micropipette tip just pokes a lot of holes in the gel. And that was when you first are doing it with groups. And if you're doing AP Bio, you're not doing a whole lot of this, but if like in biotech, you do it all year. They'll be poking holes in the bottom, which is a problem because then it leaks out all over. The MiniOnes, I've only used them once. The people that I have a full set of equipment, but I don't have MiniOnes yet. And the people that supplied them, I was like, what, these little things? But they work fantastic. They have this built-in light, the illuminator, you can actually see the DNA. I think they use a green glow or something like that.
Yeah, I forget what it's called.
We were trying to dye our DNA with Fast Blast for years, and it was just terrible. It just never really showed up. And the dye that's attached to the DNA that goes with the MiniOne kit is great, and you can really see the bands.
Yeah, thank you. And it's eco-safe. I use the BioRad stuff with Fast Blast for years, and I could get it to work, but I would always have to stain the gels overnight, which was kind of a pain because they have two different protocols for using the Fast Blast stain. And one of them they say is like, oh, you can stain it in 20 minutes. I never got that to work well, never. So I would always have to stain it overnight. So that would take up another day. And what's nice about this, the kids, and I love that they have, I don't want to sound like I'm selling this, but I just love that they have this little hood on it so the kids can put their cell phones and record it. And if they don't want to record it, they can just put their cell phones up there at the end. This is what I have them do in my classroom. I have them put their cell phones up at the end and everybody takes a picture of their gel to take home and I can assign the analysis for homework if I want. because they don't have to wait until the next day to see if their gel worked or not. And the other nice thing is, if the kids screw up, they're going to notice it right away. And this runs so fast that if you have an extra gel cup, and I always try to get 20% more reagents than what I think I'm going to need, you can really quickly set up another gel for them to run. So all is not lost. If you're doing the overnight stain, you don't know it didn't work until the next day. And then it's like, we don't got time to run that. Anyway. Okay. So I'm going to let that run. Okay, and I'm recording that on my phone, and while we're waiting for that to run, it's going to take about 15 minutes, maybe 20. I'm going to go ahead and put you guys in breakout groups for about 15 minutes or so, and when
Mary,
you're in,
sorry
yes,
to interrupt.
no,
But
please
before
go
you
ahead.
do, I've been waiting for a little bit. I wasn't sure the right time.
Go
Corey
ahead.
had written in the chat that Miramar College in San Diego runs a program with equipment training and reagents for 32 local high schools. I know there are community colleges in other regions running the Amgen and other programs. Yeah.
Thank you, Nicole. Great. You are a great chat monitor. Thank you very much. Okay. I really appreciate you guys sharing all those ideas, because you don't have to spend a lot of money to teach this course. It's always nice to have money when you're teaching science, but you can do this, and the kids can learn this even if you don't have much of a budget. So I'm going to go ahead and put you guys in breakout groups for the next 15 minutes while the gel runs. And during those 15 minutes, I want you guys to, on the Google Doc that's linked to the agenda, type in your ideas for teaching unit 3 and 4. 3 is energetics, enzymes, cellular respiration, and photosynthesis. 4 is cell communication and cell cycle. Okay, and then I'll bring us back together in about 15 minutes to take a look at our gel results.
Mary, there was one more comment from Amanda. I use Duragels for students to practice with pipettes. I can wash them between classes and reuse them for years.
Are Duragels the ones that are made of kind of like that resin?
Yeah, it's kind of this very flexible resin, so it's a little more sturdy than a real gel. So they can't like force their way through unless they're getting like really stabby. So they can get the sense of, oh, this is how deep it is without you risking all the stabbiness.
Yeah, I have a set of those. I don't think they're Duragel brand, but like you basically, what you do is you take like a mini Petri dish, like one of those 60 millimeter Petri dishes, and you put the comb across the top of the Petri dish, and you can either pour agarose in there, or you can pour a resin, a plastic resin, and then let it solidify and pull out the comb. I think if you use the resin, you have to coat the comb with like PAM, like cooking spray or something like that, so it pops back out. And then you can just pour water on top of that fake gel, and kids can practice loading the gel in there. I know MiniOne sells some pre-made plastic gels with agarose, and they keep in the refrigerator, because I bought mine about 1.5 years ago, and what I do, I just put them in a Ziploc bag and stick them back in the fridge, and I pull them out and reuse them, and they work just fine. But that practice is key. Anything else before I put you guys in your breakout groups? All right, I'm going to go ahead and do that, and I'll see you guys. I'll bring you guys all back in about 15 minutes. Let's see, I'll mix it up today, so you'll be able to work with different people this time. All right, there you go. Has Ron shown up yet? I haven't seen Ron yet. Ron, did you join us?